So what are you guys?
We are the Smartwood family!
What's the setup here? So from the homework, right, we've got this massless pulley, we've got these two masses of 10 kilograms each, there's no friction present, and this thing is moving down like this, and the question is, what's the acceleration? Okay, so as I mentioned in class before, you know this is actually technically on the high end for the MCAT. Most MCAT Newtonian mechanics problems are actually easier than this, believe it or not. Okay. But this is good homework practice, and it doesn't use anything outside the MCAT skill set. All right, so you know how to play this game. The thing pulling this guy down is definitely mg. The only thing pulling up on this guy, well, what is that? It's got to be the tension, right? So tension pulling up right along here like this, right? So we talked about this many times in class. For a continuous piece of rope on the MCAT, right, the tension is going to be the same. So this is one piece of rope, so that tension's the same. And it's like a rubber band. So on this end, this weight is yanking this guy down, so tension's going to pull back upwards. Okay, and then on this end, it's going to pull to the right. Okay. So the tension here is going to be the same throughout, opposite directions. All right, do you guys also agree that here you have mg pulling you down, but you have the normal force working against you? And since this block is not going into the table or flying off of it, these guys must cancel out, so they're irrelevant. Okay, and those are the only forces in play. So remember our shortcut from class? Since this is on actually a video format that anyone can access, and someone might not have seen what we've covered in class, I'm going to first do it the mellow way, and then I'm going to come back and do it slightly more formally. Okay? So number one, sum the forces. So I want to sum this sucker, right? So by the way, we're going to make this direction, let's say this direction here, I'm going to make this our positive direction. Okay? All right. So mg in the positive direction, so it's going to be mg. Tension, at least this first tension right here, working against this, so it's going to be negative tension. And now we go back over here. Again, remember, we're moving along this line. That's the positive direction. This tension is positive, so it's going to add in, and there's nothing else. So tensions will kill each other, like they should, and you literally have the first line, right? And all you've got is sum of forces in mg. Okay. Second, we haven't actually used Newton's law yet, so we might as well, right? So sum of forces equals ma. So we're talking about the shortcut. Let's leave that blank for the moment. M, and then the acceleration we're looking for. And that's going to be equal to mg. Okay? All right. In our shortcut, we'll do it this way. Since we added up forces over both bodies, the mass we care about is the mass for both. Okay? And on mellow problems like what you'll see on the MCAT, you know, this is a pretty safe assumption. So here, 20 times acceleration, mg, but then mg, remember, this mg only comes from this block over here. So it's got to be 10 times 10, right? It's not coming from both blocks, because what you feel from gravity over here on the left is being canceled out by the normal force, okay? All right, so now what do we have? We have 20a is equal to 100, divide both sides by 10, a is equal to 5, and that's it. Now, some of you are not used to the shortcut we've done in class, so I'm going to do this the formal way. If I'm doing it the formal way, it might be easier to just look at each body individually. So first what I'm going to do is I'm going to look at this guy up here. Okay. And for that guy, we're going to do sum of forces like before. Okay. mg is still in the positive direction, right? Because we said down along this way is positive. Okay. And the tension force is still working against it. And that's it. And then the second line, because there's nothing else, we're only focusing on the lower block. Okay, F is equal to ma, that would be the same mass times acceleration is equal to mg minus the tension. Okay, now you can plug in at this point, but we already know we have mg and we have the mass over here, but we don't have the acceleration or the tension. So we need more info. So now I'm going to go to this block on the left. So let me highlight that. Focus on this guy. Okay, that one again, mg normal force cancel out. So it's actually even easier. The only thing really working on this guy is the tension. Okay, it's going to pull in the positive direction, and that's it. And the second step is that's going to give us, it happens to be the same mass, not in every problem, but in this problem, times a. Now the key thing here is these accelerations, the way we have them set up, they're in the same direction, they've got the same sign, definitely the same magnitude, because it's a connected system. Like it's all moving together. So now what we've got, okay, the unknowns are going to be a and t and a and t. Two equations, two unknowns, we can solve this. Okay, So let's combine them. So if we add them, we're going to have basically MA plus MA, and that's going to be 2MA. And then we're going to have on the right-hand side minus tension and plus tension. They'll kill each other, so they go away. Don't forget you still have MG. And then you can cancel this. So now you're like, it's kind of different from before. Not really, because remember, M is 10. So we get 2A is equal to 10, and A is equal to 5, just like before. Now, if you're actually in the class, I definitely recommend doing it the cheap way, but anyway works. So hopefully that helped.